Hello students, I am Tanmoy. I welcome you all in my channel Chemistry, the Mystery of Molecules. So today we will discuss an important topic, or better to say latest research topic, latest topic from latest research. So this is first-order Lewis pair or FLP or first-order Lewis acid-base pair theory for hydrogenation. So it's a very important topic. So what we will discuss today? We will discuss today about the basic idea, why this is a combination, not adapt. This is one of the important question. Different type of first order Lewis acid base pair, intramolecular, intermolecular, acid atom, base atom, this even, and its application for hydrogen activation with mechanism, and finally importance of this reaction, why it is important right now, why it is so much highlighted over traditional noble metal based system. So a lot of chemistry to be learned and it's interesting, and from exam point of view I want to mention you that generally such things are not mentioned in the old books, but maybe in some recent books you may find. And right now nowadays this high exams like NET, GATE, those things, they sometimes ask some latest topic for during the question. So I believe if you know it little bit, so it will be easier for you. That's why I suggest you, please try to understand this topic. If you understand it, I guess if any question comes from in exam, it is expected that easy questions will come, not difficult. So you can answer. Okay, so let's start. So the most important point. Okay, let's discuss about the basic thing. Just focus on the words Lewis pair or Lewis acid base pair. So what does it mean by Lewis acid base pair? So if we say a Lewis acid, simple Lewis acid means lack of electron. Lack of electron. What is Lewis base? Excess of electron. Excess of electron. And if you combine them, so the combination will result in adact formation. Adact formation, which will result stabilization. Because you can think that a person is in lack of money and another person have excess money. So if the person having excess money gives to the person who is deficient of money, then both can live their life happily. Because a person have excess money, he may have the trouble that I have to secure my money, how can I secure, it may be wasted, this, and a person is striving of money. If he gets, that person may return in the future, and even that person become loyal for other person who gave him for lifetime. So instead of some excess thing, you are getting something, means peace, satisfaction. So that is the thing in chemistry point of view, if you say, that is stabilization. Because everything in chemistry point of view happens because to achieve stabilization. Now, what is happening in this case? So why I have written this PCY, this is a lone pair. So and this has a vacant orbital. It's actually 6 electron species. So this is actually a 6 electron species, and this phosphorus is a 8 electron species. So why I have written combination, not adapt? Because generally what we have seen that if you take PPH3 for example, phosphine and boron. So for example, let's take BF3. What does it happen that this phosphorus donates its lone pair to the boron? In this way, this is also 8 electron, this is also gets 8 electron and stabilized. But why not happen this? Because of steric reasons, or better to I will say that it's a designed steric reason. Better to say designed steric reason. Okay, simplest one of the example, that you have everything in your life. So why do you work? You don't need anything in your life, so why will you do some hard work? Because we do some hard work to get something, to get money, to get prosperity, promotion, etc., etc. But if you are provided a situation where you feel that you need something, then that is called design strategies. Design thing. For example, when we went to a hostel, a student during our student life, every student get same type of treatment irrespective of their family background or economic status. What this student learned, that we have to do this thing in order to survive in our life. That is a lesson. So what is the consequence of that? Consequence is that we are designed to survive in the society properly, such that we can earn, we can take care of ourselves, and even we can take care of others. Because if you are living in a society, you have to take care of yourself as well as you have to take care of others. That is the rules. So from that point of view, you can say it's a design strategy. So that's a designed social life. This is a designed state factor. So what it does? So because of this PCY3, what do I mean? If you see the cyclohexyl group, this cyclohexyl group is like that. Okay, so this, and see this, let's check this phosphorus. I should have been written its equatorial. I can draw it in this way. This. So this is the lone pair of phosphorus and need to be donated to BC6H5, where the problem lies. If you look at the boron C6H5, let me draw it here. This boron attached to why I am drawing everything in order to give you a proper visualization, because based on this visualization you will be able to understand where is the problem and what is the unique design. Okay, so that's why I am drawing everything. Please be careful, please look at carefully, and I suggest you please draw along with me, then you will learn. And such type of things I could have been skipped, but I think I should not skip, because it will help you to learn. Now, just think. This boron is having a 6 electron, and we know if you consider this means 3 group, for example, BF3, if you consider, it's the simplest example. What happens that we expect that this 3 fluorine will donate its electron density to the vacant orbital of boron. So in order to do that, they need to same plane. It is a single atom fluorine, so it will be in same plane every case, but not this case, this pentafluorotriphenyl boron. Okay, so what is the interesting? So see, if they are in same plane, there is a steric repulsion, severe steric repulsion. See, this fluorine versus this fluorine. Similarly, these versus this. Similarly, these versus these. Very high steric repulsion. So consequently, what happens? They remains out of plane. For example, we can draw in this way that this is above the plane and this is below the plane. Similarly, this thing, same thing applicable for this. This is the above the plane and rest of the thing is below the plane. So in this way, they can avoid the steric repulsion. But what is the consequence of this situation? That boron remains electron deficient. Okay, first. Second point, see, this phenyl ring, you may think that's that. Fine, 2 are out of plane, 1 is in the same plane, so why it can't donate? See, this boron is attached to 5 fluorine atom, which are electron deficient. If it is electron deficient, it will drag the electron density from the nucleus, from the benzene nucleus, and ultimately it will result in benzene nucleus electron deficient, means one step outer plane, second step due to the presence of 5-fluorine, which is a very high electron withdrawing group because of its highest electron activity. So this nucleus will become less electron deficient. Then how it will donate to the vacant orbital of boron? Consequently, boron remain electron deficient. That is the reason we call frustrated. So it need electron, but it is not able to take electron. For example, a couple, a boyfriend and girlfriend, they stay far apart. They can't see together, they can't sit together, they can't spend time together. What was the problem? Every one of them feel frustration because the other one is a source of satisfaction to a particular one. So they can't come because of the distance. So they are frustrated. And if they have some argument, means problem, then they are staying apart to each other and they are remain frustrated. Then what can do? They can talk to each other, or some friend of them can come and understand them about the thing, and they forget the problem and they come closer and stay together. In this way they both are happy, means satisfied. So previously frustrated, ultimately satisfied. And if these two friends from this girl and boy are connected together, means they are communicating that, okay, I am saying this thing to the girl, you please say this thing to the boy, such that they communicate in such a way that the problem resolves and ultimately they stay together, stay each other happily. Okay, so it is cooperating him and ultimately both are getting stabilized. So whole story, it is a way or process to get stabilized from being frustrated. This same phenomenon is applicable here. I'll explain. Okay. So what you understood? Because of this bulkiness one in phosphorus side and another is from boron side. Oh, another one. See, this is phenyl group, bulky. Another that 5 fluorine are there. So this is again bulky. So first of all, one plane is occupied by this, outer plane thing occupied by this. So this boron center totally surrounded by bulkiness. So it has excess electron. It want to give. But because of this bulkiness and this bulkiness come. So this is purely steric. So this is steric as well as electronic. So that's why they can't form adapt and they remain together. Combination. Like this boy and girl, you can think that socially people know that they are committed together. Socially they are committed. But in reality they are separated. This is happening, same thing for this. Okay. So now, as I told, that some third person's contribution is needed. Okay, before going to that, let me give you some examples. What type of could be there? So as we told that frustrated Lewis acid pair should be. So two types possible. One is intramolecular and another is intermolecular. What do I mean? In a same molecule, two first Lewis acid base pairs are there. That is called intramolecular. For example, you can think this story in this way. This 4-fluoro, I will discuss its preparation. You will get some other idea. C6H5 twice, along with that P, some R group, alkyl group. R twice. Fine, this is aromatic. This is one intramolecular in same molecule there. Or you can say this example. This is boron C6F5, better to say twice, and here in dimolecule. See, this nitrogen has its lone pair and this boron is vacant. So what is expected? That this nitrogen will donate, but if it donate, how many number of ring formation happens? It's a 4-member ring formation. See, 1, 2, 3, 4. So donation will not be that much strong. Weak donation means less stabilization. It is a design. I'll explain how this is. And intermolecular, for example, you can say this PCY3 BC6F5. Always I am showing boron. Is there another? Even phosphorus, aluminium, same group. So there are other also chances possible. As a basic video, I am not going to give you that much detail. So if you need more details, please inform in the comment box. I will give you other details. So we understood what type of combination possible. Intramolecular, intermolecular, what are the example. Now think about the process of activation of hydrogen. Okay, so when I told that, remember the story of this boy and girl. So some third person is needed in order to solve the problem between them and make them stabilized. So what it does? So, and as I told that the third person, it will be very good. It will be very good if the third person, or better to say persons, 2 persons, remain connected. So this thing we will describe in based on this hydrogen activation story. It's funny, I am also enjoying. So P CY3, it has a lone pair, or better to draw it here. And this boron C6F5. They can't combine. I have explained that's the reason. So what happens? If you provide a hydrogen, if you provide a hydrogen, see, this phosphorus is polar. This is electron rich, so better to delta minus. This is electron deficient, we can say delta plus. And because of this polarity, some polarity is induced on the hydrogen molecule. Hydrogen molecule by nature is a non-polar, but because of this it gets some polarity. So this is minus, so it will be plus. Close. This is minus. Now there is no traditional rule based on my study that okay, this Lewis base will activate the hydrogen first or Lewis acid. No, it depends on system to system which part is active, some steady electronic other factors. Okay, so this fine. So what happens? You can consider this will give its pair to him, and consequently with lone pair it will go to there. Question why? Previously I have explained that it is electron rich, it is deficient. They can't solve their deficiency problem or crisis like this girl and boy. They can't resolve. They are under frustration. Okay, because of this separation. So they need third one. And what this third one is doing? This third one is means it is acting as a source of proton, it is acting as a source of hydride. Means this part is electron rich, this part is electron deficient. It is deficient, that's why it can stabilize this electron rich part. It is electron rich means hydride, that's why it can compensate the hunger of electron of this boron. So what happens? CY3PH plus and hydrogen B C6F5 thrice. This is a minus. It is better to write in this way. Fine. So now, what we are able to achieve? We are able to achieve the proton splitting. Proton splitting. What is the advantage? See, hydrogen is a very inert molecule, non-reactive. But see, it has a H plus, it has a H minus. So they can undergo reaction. Okay. So what type of reaction they can do? For example, imine hydrogenation. This is carbon, this is nitrogen. Now, since it is a hydride, so this hydride H minus could be shifted here. And when it hydride would be shifted here, so after that there will be a carbon hydrogen bond. this, and these will open up to be provide N minus, and that N minus will abstract this hydrogen. So in this way, see, two hydrogen, one from this boron here hydride, one from this here hydrogen. So now the question is, so what they are acting? Catalytic hydrogenation. Catalytic hydrogenation. So actually this combination act as a catalyst to split hydrogen and do some hydrogenation reaction. Now you can ask me a question, that's that previously they were unstable, frustrated. After that they got some stabilization, happiness. Why they will give? Nobody wants to give up their reason for frustration, satisfaction to someone else. Nobody wants. Me also, I don't want. But why it is happening? This is the role of catalyst, or better to say design. This is not highly stable. This combination is moderately stable. Moderately stable. What is the definition of a catalyst? It will react with the substrate and provide moderate stability. If it reacts with the substrate and make it very stable, then why the substrate will react to form some product? Not possible. And if the substrate does not get some stability with the catalyst, then why the substrate will react to the catalyst? So it's a moderate, it's a optimum situation. So this is the optimum situation. What happened? Again this combination will be generated, then again it will react with hydrogen. In this way the catalytic cycle will go on. Okay. Now I have discussed about the intermolecular part. Let's discuss little bit about the intramolecular. I mean this example. So they can't satisfy their need of, means their crisis, need of electrons, or better to say proton. So if you put a hydrogen to them, what happens? Similarly this will become H plus, delta minus. So consequently this nitrogen lone pair gives, and it comes. Now question, why this will happen? Just count the ring. What do I mean? 1, 2, 3, 4, 5, 6. So transition state TS is 6 member. That's why it happens. This is the intramolecular fashion. Okay. Now let's discuss little bit about the preparation of this FLP. As I told, little bit, very slow. So how this could be prepared? And another thing, please keep in mind, fluorine has a very important role here because of its smaller size and higher electronegativity. Okay, so this is the utilization of electronegativity of fluorine. Now let's discuss about this. How this is happening? You can explain this. First of all, how this is prepared. First of all, this pentafluoro triphenyl boron is taken. So boron, I am not writing, C6F5 is taken. Now it can have another canonical form. We know boron is a 6 electron species, electron division. So you can say that this can come here, this can come here. So what will be the canonical form? Other canonical form possible. I am just focusing on this canonical form. So this boron C6F5, this minus, and here fluorine this plus. Now question will come, why I am focusing it? How it is stabilized? It could be stabilized by the conjugation of the lone pair of fluorine. I know fluorine is electronegative, but halogen are having minus I and plus R effect. So plus R effect is responsible to stabilize it, but that stabilization will not be very high. Consequently, if you take with this a phosphorus reagent, for example R2PH, and react with this phosphorus has lone pair, so it will attack. Now you can ask that, sir, why not ortho? Ortho has some positive charge also. I agree, but remember, I have showed why this pentafluorotriphenyl boron center could not be accessed because of the bulkness. So that bulkness will affect these two center also. So reaction will not happen. Fine, it will attack. So what is the consequence after that? So this all fluorine will remain intact. So if it attacks, then similar B. For example, let's consider Ar2. Let's consider this as Ar. So Ar2 minus, this is the fluorine and this is the Pr2. One hydrogen was there, means after attacking. So this hydrogen will be eliminated in order to neutralize the charge. So fine. Next step, what is expected? This system want to gain aromaticity, so what can happen? It can push back. Boron is Lewis acidic, it wants, but it is not true that it will keep it to itself forever. It can't. So it will come. Now fluorine will leave because it's a good leaving group more compared to Pr3 because more electronegative. So what it generate? It generate. This is the Pr2. This B Ar2, this fluorine, 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 fluorine. Now, please keep one thing in mind. The H plus was eliminated. That can remain to this because phosphorus is a lone pair. So instead of that, it is better to write in this way. So Pr2H P plus. Fine. And there was a fluorine. So fluorine left from here, but see, boron is electron deficient. So fluorine will donate. Be attached here. Now my question will come, sir, why this fluorine is getting attached to boron? Because fluorine is very small atom. They couldn't come together because of these bulky groups. But fluorine is a very small size. That's why it can combine. So what we get? Actually, we wanted to get hydrogen. This is in forms of delta plus. Another we wanted to have some minus. So how that thing could be achieved? So that thing could be achieved by, then see, we have a proton source, but we need a hydride. So we need to add a hydride source. For that purpose, what is used? The reagent used is diethyl chlorosilane. Okay. What happens? This hydride is transferred to boron and this fluoride removes and go and attach to this silicon. Now a question will come, why this boron fluorine bond is very stable? We know why this is going, because silicon fluorine bond is also very stable. That is another front. See, that directed alveolar condensation or deprotection of silyl ether to form and enolate, to generate enolate. You have read this story, I have explained. Please visit that video if you are little confused. So what happened? So right now see, let's see this. See, already had a hydrogen attached here. This is plus, and this hydride went and attached there, H minus, and this fluorine is attached to prepare Et2. So its consequence SiClF. So this is the thing. See, I should not write the negative charge on this because the negative charge should go on the final boron atom. So what overall we got? We got this frustrated Lewis acid pair combination. So this hydrogen, and if they combine, they can generate hydrogen. And in reality, what happens? Actually, this is the beauty of FLP also, I would rather say. So what is the beauty? Beauty is that if you heat them, means it's a reversible thing. If you read them 100 degree like that, this hydrogen will be eliminated. Means it will generate the original catalyst. Means you can say reversible hydrogen binding mediated by heat. It's an interesting, it is a very interesting thing. Pr2. Okay, plus hydrogen. And if you reduce the temperature, it will come. So this is the overall, this was actually, it is reversible hydrogen binding. Means this is an ideally designed substrate for catalysis. Okay. So if you put any substrate like imine, that hydrogen, this part will be consumed. So again new hydrogen will sit and bring the equilibrium in this way. Fine. So this is now one important thing, the last point, that is the importance of a noble metal based catalysis. We know what noble metals are used. Noble metals are used for hydrogenation. I have already uploaded a video. What is that? What are them? Platinum, palladium, nickel. Better to remove nickel or iridium, gold. There are things nickel, cobalt, but not that much active. Mainly active this noble metal series. Okay, ruthenium, rhodium, etc. So what is the problem? They are noble metal. First of all, abundance is low. Second thing, they are costly. Third, they are poisonous. So what is the choice? Choice is that nickel, cobalt, those things, 3D condition metal. But they have some problem also, low reactivity. And second thing, they are also transition metal. I agree that they have low toxicity compared to them, but they also have some toxicity. And there was a previous thought that without no metals you can't activate hydrogen. So that myth was broken by this strategy, or this FLP strategy, or Lewis acid base pair strategy. Okay, so that is the uniqueness of this synthesis strategy over noble metal based system. So this is the importance of them over this, because they are metal free system, and right now metal free, or sometime if you consider aluminium, those things, if you leave them, noble metal free. Those are highly appreciated right now from green chemistry point of view. Nowadays we are very much concerned about the environmental consequence of chemistry, because we are using toxic material where we are dumping in our parent earth, and we are taking food. For example, we are dumping in sea, and we are getting food from sea, that is sea fish. So we are getting affected. So actually we are destroying our health because of our wrong choice. So it's time for us to develop some new chemistry or methodology such that this problem could be handled. And the method which is useful, that is sustainable chemistry or green chemistry. So this chemistry is important. I believe it has lots of limitation, it is true, but it is a beginning of a new era. Okay, so this is the overall discussion. So what we have learned today? We have learned today this frustrated Lewis acid base pair strategy. Why they are frustrated, mechanism of activation of hydrogen, means split hydrogen into hydride and proton, and ultimately reduction of imine, those things. Some other also chemistry there, alkene reduction, those things. So this we learn, and ultimately we have discussed about preparation of a Lewis acid base pair and showed that it binds hydrogen reversibly. That is the biggest advantage of this. So if there are other reactions also, if you want to learn, please mention in the comment box. Based on your response, I will try to make the second part where you will learn it extensively. It's a very interesting topic. So thank you. So thank you everyone for your patience. If you really like my teaching, I request you, please help my channel to grow. First of all, subscribe my channel Chemistry, the Mystery of Molecule, and please press the bell icon to get the notification of every single video I upload. Secondly, share this video among your friends so that many people could be benefited, and specifically for this is a very new topic, so they will be aware also, it may help them. And thirdly, please like this video, make some good comment if you really feel it's good, but if you feel that some modification, rectification is essential, please mention in the comment box, because your suggestion is the motivation for me to improve further, and in return you will also get some good chemistry videos. So thank you everyone, stay motivated and motivate me also. Stay happy, stay blessed. See you in my next video.